Good day everyone, we're from 11 STEM 4. We're not here to talk about pizzas, but we're here to discuss the different layers of the Earth. However, you can think of the layers of the Earth as a giant big pizza piece.
The Earth's crust, that's the crispy golden crust. It's thin but holds everything together, just like the Earth's crust does with continents and oceans. Beneath it, we've got all the gooey molten layers of cheese and sauce, like the mantle and core that makes up most of the Earth. The crust might seem like a small part of pizza, but without it, everything would be messy and a molten disaster.
Welcome to the surface of the Earth, where we live. Think of it as the skin of the planet, but it's not just one piece. It's made up of plates.
This is the outside layer of the Earth, and is made of solid rock, mostly basalt and granite. It is thinnest layer ranging from 5 to 70 kilometers thickness, and it is divided into two types of crust, oceanic and continental.
Did you know the oceanic crust is denser and thinnest layer of the Earth crust, and it found under the ocean basalt and mainly composed of basalt, while the continental crust is less dense and thicker layer than oceanic crust, and it is found under the continents and mainly composed of granite.
The other fact about crust is it is made out of solid rocks and minerals and is divided into several large tectonic plates. These plates are constantly moving and interacting with each other, which can result in earthquakes, volcanic activity, and the formation of mountains.
As we dig deeper, we enter the mantle, a layer of hot semi-molten rock. It's like lava waiting to erupt from a volcano.
The mantle refers to the layers of the Earth interior located between the crust and the core. It composed of semi-solid rock that flows slowly over geological timescale. A mantle is a type of cloak or heavy overcoat that covers the shoulders and arms, often worn for warmth or protection.
Fun fact: it's mostly solid, but it flows. While the mantle is primarily solid rock, it behaves like a very viscous fluid over long periods. This slowly movement, called convection, drives plate tectonic and causes earthquakes and volcanic eruptions.
Now we're entering the outer core, where things get really interesting. This part is like a giant ocean of molten metals.
The outer core is made of mostly nickel and iron. It is always at high temperature, ranging from 4,500 degrees Celsius to 6,000 degrees Celsius. The hottest part of the outer core is approximately the same temperature as the sun. The outer core creates an Earth magnetic field which protects all life on Earth.
Did you know that it also plays a key role in generating the planet's magnetic field? Here's how it works. First is molten metal motion. The outer core is in a liquid state due to the intense heat, which causes the molten metal to move and swirl around as the Earth rotates.
Second is convection currents. Heat from the inner core causes convection currents in the outer core, where hotter, less dense material rises and cooler, denser material sinks. This movement of molten metal generates electric currents.
Third is the dynamo effect. As the molten iron and nickel move, they carry electric charge with them. The motion of this charge particles create magnetic fields. This process is known as the dynamo effect. It is what's generate and sustain Earth's magnetic field.
We reach the inner core. It's like a giant super hot metal ball. It's so solid because of the intense pressure of heat.
The innermost part of the Earth is the core, and it is about 1,500 by 2,414 kilometers deep. and the inner core is the innermost layer of the Earth. It has several unique properties that help distinguish it from the other layers due to interaction between the inner and outer core. Earth generates its own magnetic field. The inner core is also incredibly dense and composed primarily of iron and nickel.
A fun fact about Earth's inner core is that it is actually growing over time. As the planet cools, more molten materials from the outer core solidifies and becomes part of the inner core. However, this process is not even one side of the inner core grow faster than the outer. Specifically, it's growing more quickly Venet Indonesia than Venet Brazil, creating an interesting asymmetry in Earth's structure.
We've explored all the way from the crust where we live to the fiery depths of the core. Isn't the Earth incredible?